When you think of the earliest mathematical thinking, what comes to mind? Maybe the ancient Greeks, like Pythagoras or Euclid? Or perhaps the Egyptians with their monumental pyramids? Well, what if I told you that we need to rewind the clock much, much further back? We're talking about a time 8,000 years ago, long before the first cities or written languages. Recent discoveries are showing us that our prehistoric ancestors weren't just surviving. They were thinking in numbers, patterns, and geometry, and they were expressing it in the most beautiful way imaginable, through art. Imagine a world just emerging from the Ice Age. Small communities are learning to farm for the first time, settling down in one place. This is the setting for the Halafian culture, a society that flourished in northern Mesopotamia, in what is now parts of Turkey, Syria, and Iraq. Around 6000 BCE, they didn't leave behind written records or grand monuments. Instead, they left us something perhaps even more intimate, their pottery. And this pottery is not just a collection of old clay pots. It's a window into the minds of our ancestors, and it's revealing something astonishing. A new study published in the Journal of World Prehistory is turning our understanding of early human intellect on its head. Researchers took a deep dive into the painted pottery of the Halaf people, and what they found was not just decoration. They found mathematics. Embedded in the intricate designs were sophisticated concepts of number, space, and order. These early farmers, it turns out, were pioneering mathematical ideas thousands of years before we thought possible. So what exactly did they find? Let's look closer at these ancient artworks. The Halafian pottery is famous for its stunning, detailed patterns. You'll see geometric shapes, swirling lines, and something very special, botanical art. These aren't just random doodles of plants. The researchers analyzed hundreds of these painted vessels and discovered a hidden language of numbers. The artists seemed to be intentionally using specific numerical patterns. For example, they consistently painted flowers with a specific number of petals or grouped elements in sets of 4. This wasn't a coincidence. The repetition across so many different pieces of pottery points to a shared, understood system of numerical representation. Think about what this means. These people were using art to convey numerical concepts. A pot decorated with a plant bearing 4 leaves wasn't just a picture of a plant. It was also a representation of the number 4. This concept is called numerosity, the ability to understand and represent numbers. Before this discovery, the earliest evidence of this kind of abstract numerical thinking was thought to be much more recent. The Halafians were doing it 8,000 years ago. But it goes even deeper than just counting. The way they arrange these designs reveals a profound understanding of geometry and symmetry. The researchers noticed that the patterns often display rotational symmetry. This is when you can rotate an object and it still looks the same. For instance, a 4-petaled flower looks identical whether you turn it 90, 180, or 270 degrees. This isn't a simple concept. It requires abstract spatial reasoning. The Halaf artists were deliberately creating balanced, symmetrical compositions that were mathematically precise. They were, in essence, early geometers exploring concepts of transformation and order. One of the most mind-blowing aspects of this is the idea of multiplication or grouping. The artists didn't just paint one flower with 4 petals. They would paint a series of these flowers around a bowl. If a bowl has 6 flowers, each with 4 petals, you have a visual representation of grouping or even a precursor to multiplication. This suggests they were not just counting individual items, but were thinking about numbers in relation to each other, forming sets, and understanding proportionality. The entire design of the pottery was a canvas for complex combinatorial ideas. So why were they doing this? Why embed mathematical concepts into their pottery? The researchers believe it was deeply connected to their new way of life, agriculture. Farming is inherently mathematical. You need to keep track of seasons, count seeds, measure plots of land, and distribute resources. The cyclical nature of planting and harvesting is all about patterns and time. The researchers proposed that these botanical paintings were more than just art. They were a cognitive tool. By painting these structured, numerical patterns onto everyday objects, the Halaf people were reinforcing and communicating the very concepts they needed to thrive as an agricultural society. It was a way to make abstract ideas tangible. A child growing up in a Halafian village would be surrounded by these patterns. They would eat from bowls decorated with symmetrical flowers and drink from cups adorned with repeating geometric motifs. This constant exposure would have been a form of education, embedding these foundational mathematical principles into their culture and their very way of thinking. It was a way of standardizing information, of creating a shared visual language for concepts like quantity and order, which were crucial for community planning and survival. This discovery completely reframes how we view prehistoric art. It's not just primitive decoration, it's a sophisticated information system. It shows us that the line between art and science is a modern invention. For our ancestors, they were one and the same. The drive to create beauty was intertwined with the need to understand and structure the world around them. The aesthetic appeal of symmetry and pattern was likely linked to the cognitive satisfaction of order and predictability, things that are incredibly valuable when you're trying to build a stable society from the ground up. Let's think about the timeline here. This was happening around 6000 BCE, that's about 3,000 years before the first pyramids were built in Egypt, and over 3,000 years before the development of cuneiform, one of the earliest forms of writing in Mesopotamia. These early farmers were engaging in complex symbolic thought and mathematical reasoning without a written language. They were using a visual, artistic language to do the heavy lifting of abstract thought. It's a powerful testament to the ingenuity of the human mind. This research also challenges the idea that major intellectual leaps only happen in large urban civilizations. The Halaf culture consisted of small, scattered agricultural villages. Yet they were the ones laying the groundwork for mathematical thinking. It suggests that the cognitive tools necessary for complex societies were developed not in the bustling cities, but in these small, early farming communities. The very act of settling down and cultivating the land may have been the catalyst that sparked this intellectual revolution. What's next for this field of study? This is just the beginning. Researchers are now looking at other prehistoric cultures to see if they can find similar patterns. Is this phenomenon unique to the Halaf people, or was this a more widespread stage in human cognitive development? Imagine what else might be hidden in plain sight, in the patterns on a piece of pottery, the carvings on a bone, or the layout of an ancient settlement. We are just scratching the surface of understanding the intellectual world of our deep ancestors. This discovery is a beautiful reminder that the human quest for knowledge, for order, and for beauty is ancient and universal. Long before spreadsheets and calculators, our ancestors were exploring the world of numbers and patterns with clay and paint. They show us that mathematics isn't just a subject in a textbook. It's a fundamental part of how we perceive and shape our world. The art they left behind is not just a relic of the past. It's a message, a time capsule of the moment our ancestors first began to count, to measure, and to see the beautiful mathematics hidden in a simple flower. So the next time you see a piece of ancient art, look a little closer. Don't just see the image. Look for the pattern, the symmetry, the numbers. You might just be looking at the birth of an idea, an 8,000-year-old whisper from the dawn of human civilization, telling us that they were more like us than we ever imagined. Thanks so much for watching. If you found this as fascinating as I did, please hit that like button and subscribe for more deep dives into our incredible human story. And let me know in the comments what you think about this discovery. Could art really be the origin of math? I'd love to hear your thoughts. See you in the next one.